This channel wants to agree that the most crucial aspect of AI and AGI would be maintaining human control and ensuring that AI and AGI development and deployment align with human values and enhance rather than diminish human capability and purpose. Maintaining mental privacy is a challenge with these technologies. Protecting internal thoughts and emotions from AI analysis, maintaining spaces for unmonitored human interaction, and preserving intimate human relationships without AI intervention are also challenges. We will touch on all of these concerns as well. Please be open-minded to analyze these topics. I would like to read your comments about how AI and AGI can affect or is impacting your life. The Alan Turing Institute adds that bias and discrimination could be a challenge too, because they gain insights from the existing structures and dynamics of the societies they analyze. Data-driven technologies can reproduce, reinforce, and amplify the patterns of marginalization, inequality, and discrimination in these societies. Likewise, because many of the features, metrics, and analytic structures of the models that enable data mining are chosen by their designers, these technologies can potentially replicate their designers' preconceptions and biases. Finally, the data samples used to train and test algorithmic systems can often not represent the populations from which they draw inferences. This creates real possibilities of biased and discriminatory outcomes because the data being fed into the systems is flawed from the start. This video will overview the key differences between AI and AGI. AI, or artificial intelligence, refers to systems designed to perform specific tasks using computational methods that mimic aspects of human intelligence. These systems are narrow or specialized. They excel at particular functions like image recognition, language processing, or game playing, but only within their trained domains. For example, an AI might be excellent at chess but unable to drive a car or understand natural conversation. AGI, or artificial general intelligence, represents a hypothetical future AI system that would possess human-like general intelligence, the ability to understand, learn, and apply knowledge across different domains just as humans do. An AGI would be able to transfer knowledge between different fields and tasks, learn new skills without specific training, understand and respond to novel situations, demonstrate self-awareness and consciousness, though this is debated, and match or exceed human-level performance across virtually all cognitive tasks. Currently, we only have narrow AI systems. Despite recent advances in AI capabilities, we haven't achieved AGI, and there's significant debate in the scientific community about when or if we will achieve it, what form it might take, and what implications it might have for society. The key distinction is that current AI systems are specialized tools for specific purposes. At the same time, AGI would be a generally intelligent system comparable to human intelligence regarding flexibility and breadth of capability. I want to add a definition of common sense for a later explanation. Let me do that. Common sense is the ability to make reasonable judgments and understand practical situations based on lived experience, basic knowledge, and an intuitive understanding of how the world works. Let me break this down with examples. Basic physical understanding. Knowing that water will spill if you tip over a full glass. Understanding that a ball will roll downhill, not uphill. Realizing that ice is slippery and hot objects can burn. Practical social knowledge. Understanding that someone crying might need comfort. Knowing to lower your voice in a library. Recognizing that a formal job interview requires professional attire, causal reasoning. If dark clouds gather and the wind picks up, it might rain. If you don't water a plant, it will eventually die. If you're late to work repeatedly, you might face consequences. Contextual adaptation, knowing when humor is appropriate versus inappropriate. Understanding that the same action, like touching someone's shoulder, can be comforting or threatening depending on context. Recognizing when to be formal versus casual in communication. Risk assessment, not walking into traffic without looking. Being cautious around electrical outlets when wet. Understanding basic food safety, like not eating moldy bread. What makes common sense particularly interesting is that it's often unconscious. We apply it without actively thinking. It's culturally influenced. What's common sense in one culture might not be in another. It's learned through experience. It develops over time. And it's difficult to program. It's one of the biggest challenges in AI development because it involves implicit knowledge that's hard to codify. Interestingly, what we consider common sense often isn't common. It's a sophisticated set of learned behaviors and understandings we've internalized so deeply that they seem obvious or natural. Let's continue with AI and AGI. I will expand on this and give examples of how AGI would be a generally intelligent system comparable to human intelligence in its flexibility and breadth of capability. Let me illustrate how AGI would compare to human intelligence through concrete examples. Consider how a human child learns and adapts. They can learn to ride a bicycle and then naturally apply those balance principles to learning to skateboard. They can learn addition with apples, then instinctively apply it to counting money or sharing cookies. They understand that a chair is for sitting whether it's made of wood, metal, or plastic. And even if it has a novel design they've never seen before, an AGI system would demonstrate similar cognitive flexibility. Here's how it might compare to the current narrow AI Scenario 1 kitchen tasks. Current AI might excel at identifying ingredients in photos or following recipes, but each task requires separate specialized systems. Human AGI could walk into an unfamiliar kitchen, figure out where things are stored based on common sense, improvise when missing ingredients, and create new recipes by understanding flavor combinations and cooking principles. Scenario 2, problem solving. Current AI can solve specific types of math problems or play specific games at superhuman levels. Human AGI could learn the rules of a new board game and quickly develop strategies, then apply similar strategic thinking to business negotiations or urban planning. Scenario 3, social interaction. Current AI can engage in scripted customer service conversations or generate contextual responses. Human AGI would understand subtle emotional cues, cultural contexts, and implicit meanings, adjusting communication style based on the situation, whether comforting a friend, negotiating a deal, or teaching a child. Scenario 4, creative adaptation. Current AI can generate art in specific styles or compose music following patterns. Human AGI could combine concepts from different fields to solve problems, like applying principles from nature, biomimicry, to architectural design, or using music theory to explain mathematical patterns. Scenario 5, physical world navigation. Current AI specialized systems for specific tasks like robot navigation or object manipulation. Human AGI could navigate any new environment, use unfamiliar tools by understanding their purpose, and adapt to unexpected physical challenges like finding a way around a blocked path or figuring out how to move heavy furniture through a narrow doorway. The key difference is that AGI would possess common sense reasoning, causal understanding, not just pattern recognition, abstract thinking ability, emotional intelligence, self-awareness, ability to learn from minimal examples, and capacity to generate novel solutions by combining knowledge from different domains. Fundamentally, AGI would mirror human cognition's most remarkable feature, the ability to face entirely new situations and figure them out using prior knowledge, reasoning, and creative problem solving. This goes far beyond current AI systems, which, despite their impressive capabilities in narrow domains, lack this kind of generalized intelligence and adaptability. Let me explain how AI and AGI could help humanity and then explore the timeline and implications of AGI integration. Current AI benefits. First, let's talk about healthcare. AI is making waves in early disease detection through medical imaging analysis. It's also accelerating drug discovery and development, offering personalized treatment recommendations, and even providing mental health support through therapy chatbots. Next, we have environmental protection. AI aids in climate modeling and prediction, optimizes renewable energy systems, helps in wildlife conservation through automated monitoring, and manages resources smartly to reduce waste. In education, AI offers personalized learning paths for students, automates grading and feedback, assists in language learning, and provides accessibility tools for disabled students. Lastly, in scientific research, AI excels in data analysis and pattern recognition, simulates complex systems, accelerates experimental design, and synthesizes literature reviews. Now let's imagine the potential benefits of AGI in the future. For scientific breakthroughs, AGI could solve complex problems like nuclear fusion, find cures for currently incurable diseases, develop new materials with revolutionary properties, and help us understand consciousness and brain function. When it comes to global challenges, AGI could create comprehensive solutions for climate change, design sustainable economic systems, solve food and water security issues, and optimize global resource distribution. On a personal development level, AGI could act as universal tutors adapted to each person, provide personalized health and wellness guidance, offer life coaching and career guidance, and support emotional and psychological growth. In terms of infrastructure and planning, AGI could design optimal city layouts, manage global supply chains, coordinate disaster response, and develop sustainable transportation systems. The integration of AGI into society would likely be gradual and could take several decades. In Phase 1, which would be 5 to 10 years after development, we'd see initial deployment in controlled environments, testing and safety verification, development of regulatory frameworks, and limited integration in critical sectors. Phase 2, spanning 10 to 20 years, would involve broader implementation in professional fields, integration into public services, adaptation of the education system, and modernization of infrastructure. Phase 3, taking place over 20 to 30 years, would see full social integration, economic system adaptation, new forms of human AGI collaboration, and cultural and societal adjustments. The complete settlement of a world with AGI would likely take 30 to 50 years after its initial development. This would require building new social structures, developing new economic systems, creating new educational approaches, establishing new governance models, adapting cultural norms and values, and evolving human roles and purposes. This timeline assumes the successful development of safe and beneficial AGI, which is uncertain and debated among experts. The key would be to ensure that the integration process prioritizes human flourishing while maintaining human agency and purpose in a world where AGI systems augment intelligence. Let me break down each of these critical social challenges with potential solutions. For job market transformation and preventing poverty, we could implement universal basic income, providing a basic standard of living during the transition, funded through AI/AGI-generated economic gains, allowing people time to retrain and adapt. Skill evolution programs could offer free retraining for displaced workers, focusing on uniquely human skills like creativity, emotional intelligence, and complex decision-making, and developing new job categories that complement AI capabilities. Human-AI collaboration roles could involve training people to become AI-human interface specialists, creating positions for AI output verification and quality control, and developing roles for ethical oversight and decision-making. In education, new teaching methodologies could shift from information delivery to facilitating critical thinking, teaching students how to effectively collaborate with AI systems, and focusing on developing students' unique human capabilities. Professional development would involve continuous training in AI/AGI capabilities and limitations, learning to use AI as a teaching assistant rather than seeing it as competition, and developing curricula that combine human insight with AI capabilities. New assessment methods would move away from memorization-based testing, focus on evaluating creative problem-solving, and develop metrics for measuring human-AI collaboration skills. For cultural adaptation, social integration would involve developing new social norms for human-AI interaction, maintaining human communities and relationships, and creating spaces and activities that celebrate human creativity and connection. Value systems evolution would redefine success and achievement in an AI-augmented world, emphasize uniquely human qualities and contributions, and develop ethical frameworks for human-AI coexistence. Work-life balance would involve redefining the role of work in human identity, creating meaningful activities beyond traditional employment, and developing new forms of social contribution and purpose. Privacy concerns would be addressed through data protection, developing robust personal data protection systems, establishing clear boundaries between shared and private information, and ensuring individual control over personal data usage. Surveillance issues would involve establishing limits on AI monitoring capabilities, creating AI-free zones for genuine privacy, and developing privacy-preserving AI technologies. Identity protection would prevent unauthorized AI impersonation, protect personal behavioral patterns from exploitation, and maintain autonomy in decision-making. Mental privacy would involve protecting internal thoughts and emotions from AI analysis, maintaining spaces for unmonitored human interaction, and preserving intimate human relationships without AI intervention. Data rights would establish ownership rights over personal data, control over how AI systems use personal information, and the right to be forgotten and data deletion. Ethical boundaries would involve clear guidelines for AI data collection, transparency in AI decision-making affecting individuals, and protection of vulnerable populations. The key to addressing these challenges lies in proactive planning and policy development, strong regulatory frameworks, public education and engagement, gradual implementation with continuous assessment, maintaining human agency and choice, and creating safety nets and support systems. Success will require collaboration between government bodies, educational institutions, private sector companies, civil society organizations, technology developers, ethics committees, and public representatives. The goal should be to create a transition that enhances human capabilities and opportunities while protecting fundamental human rights and dignity. Please, in the description, you have sources to continue reading about this topic. If you like this type of video, consider subscribing to the channel. Thank you for watching.